Hi everyone, this is Mrs. GA, and today we're going to learn how to graph absolute value functions. Alright, before we get started, a quick warm-up. So go ahead and pause the video and give these problems a try, and we'll check your answers in just a few seconds. Alright, let's go ahead and check. So here we were using those transformation rules we learned about in the last video. So remember, anytime we're adding or subtracting, it's going to be a translation or a shift. So if we are adding or subtracting grouped with x, it's going to go left or right. So we just have to remember this always moves in the opposite direction. So since we're subtracting 2, it's actually going to translate our graph to the right 2. Now here, you can see that we added 3 to the entire function, so it's not grouped with x, so it's up or down, and this just moves your graph up 3. Anytime we multiply by a positive, it's a stretch or shrink, so this is a vertical stretch by a factor of 2. And then here, anytime we multiply by -1, it's a reflection, so we're multiplying the entire function. So if you multiply the entire function, it reflects over the x-axis. So it's a vertical reflection over the x-axis. Okay, so today we are going to be working with absolute value functions. So this is what we call the parent function for our absolute value. Y equals absolute value of x. So a parent function is kind of going to be our starting place for any new function that we learn. And you can find it by simply making a t-chart, a table of values, and you would see that you get a graph that looks like this. So we have a point at the origin, 0, 0, and then we have 1, 1, 2, 2, 3, 3, and then -1, 1, -2, 2, -3, 3, so on and so forth. So it kind of looks like two linear functions that have come to a point. So the domain of our parent function is going to be all real numbers. So it's -infinity to +infinity. Remember, domain is all the x values. So this shows that our graph will keep moving to the left and right forever. And then our range, we can see, is everything from 0 and above. So remember, range is the y value, so it's from 0 to infinity, including 0. Here you have the end behavior. As x approaches -infinity, y approaches infinity, so moving to the left, our graph goes up. And as x approaches +infinity, y approaches +infinity, so moving to the right, our graph also goes up. And then a few other, one extra thing, we can call this the vertex of our graph. It's going to be an important point of our graph. And again, this is our parent function. So this is kind of our starting place, and then we can use transformations to help us graph accordingly when our equation changes. So to graph absolute value functions using transformations, really, we just need to understand 3 different things that may happen, or 4 different things actually. So we have these, and there's one extra that we will add as well. So again, if we are multiplying our entire function by some positive value here, this is going to be some type of vertical, stretch, or shrink. Alright, so the next thing that we see is some number being added or subtracted specifically from x. So this is going to be a translation, which is just a shift. And remember, since it's affecting the x, it's going to go left or right. And please remember, this negative should help you remember it's going to move in the opposite direction. So the negative tells us opposite direction. And then if we see something added or subtracted outside of the absolute value signs, like we see here, it's still a translation, so it's a shift. But since it's outside the absolute value signs, it's going to affect your y value. So it's going to go up or down. Now the last one, it's not shown in the equation, but if that a value, if attached to the a value is also a negative, so if we're multiplying by a negative in front, A negative will reflect our graph. So if negative, it's going to be a reflection. It will be a vertical reflection, which will go over the x-axis. So today we're going to be looking at equations, and we're going to be interpreting what type of transformations occur, and we're going to use them to help us transform the coordinates and the graph of our absolute value functions. Alright, so let's start with example 1 together. So we're going to transform the coordinates of the parent function, p of x equals absolute value of x, to graph f of x equals x, absolute value of x plus 2 minus 4. And then we're going to graph that function. We'll also practice listing the domain and range. So first we're going to look at this and see if we can determine what the transformations are, and we're actually going to write them out. So the first thing we notice here is that we are adding 2 to x. So remember, this is going to shift left or right because it's grouped with x, and it moves in the opposite direction. So this is actually going to shift or translate left 2. Then the other transformation we see is right here. Since we're subtracting 4 outside of the absolute value signs, this is going to shift our graph down 4. So we have 2 translations, left 2 and down 4. So now we're going to see if we can use these to help manipulate our coordinates. So first we're going to list out the coordinates from our parent function. So we'll list out coordinates from this function p of x. And let's change this to p of x. Sorry, that should have said p of x. So we'll pick some x values. We'll say -2, -1, 0, 1, 2. Those are good ones to always start with. The absolute value of 2 is -2 is +2, then +1, 0, 1, and 2. So again, we're just substituting the x values here. So these are our parent function coordinates, and you can graph this if you would like. So I'll graph it for this first one. So remember, our parent function looks like this. It's a V-shaped graph with the vertex at the origin, just like this. Now, we're going to see if we can make all of our points go to the left 2 and down 4. So if I want to move to the left 2, right, that means to all of my x values, I should subtract 2. So my rule here is going to be x minus 2. And if I want to move down 4, that means I should subtract 4 from all of my y values. So we're going to do y minus 4. Okay, so I'm going to take all of my x values here, and I'm going to subtract 2. So let's do that first. So -2 minus 2 is -4, and then we have -3, -2, -1, and 0. So again, we're just moving all of our x values to the left 2 by subtracting 2. Then we're going to move all of our y values down 4 by subtracting 4. So we can go through and do that. So we'll do 2 minus 4 is -2, 1 minus 4 is -3, and then -4, and then -3, and then -2. So these are going to be the coordinates of our new graph. So we can plot these 5 coordinates, and I'll plot it using blue. So we have -4, -2, -3, -3, -2, -4, -1, -3, and 0, 2. And then we can continue the lines on to the left and to the right. So this is what our graph looks like. So you can see that if you take the vertex, and we have shifted everything left 2 and down 4. So we've achieved the appropriate transformations. Now let's see if we can describe the domain and range of this function in blue. So here's f of x. Remember, this was p of x. Okay, so for the domain, again, it's all of the x values. Since I'm going to the left and right forever, it's all real numbers, and we'll do -infinity to +infinity. And for the y values, I can see my lowest point is at -4, and then it's everything above. So -4 is included, and that's our lower boundary, and then it will keep going up to positive infinity. And then we are all done. Okay, let's try another one together. So here again, make sure, let's change this to p of x. Okay, so we're going to transform the coordinates of the parent function to graph f of x equals -1/2 times the absolute value of x minus 1. So first, let's see if we can list the transformations that we see. I do see a negative here. So this negative in front will be a reflection. So we're going to reflect over the x-axis. It's a vertical reflection. And then we see that we're multiplying by 1/2. So that's going to be a vertical shrink by 1/2. And then last, I see that we are subtracting 1 from x. So this is going to be a shift to the right by 1. So remember, this always moves in the opposite direction. So we have 3 different transformations here. And first, we're going to see if we can transform our coordinates by creating a rule. So let's start with those same parent function coordinates. So we have -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. And again, that just comes from our parent function, absolute value of x. So now we need to create a rule to change our x's and our y's accordingly. So the only change to x is going to be that shift to the right one. And if I want to move all of these to the right one, I'm going to add 1 to the x values. So it's going to be x plus 1. That'll be the rule here. And then if I want to reflect over the y-axis and do a vertical shrink by a factor of 1/2, I need to multiply, just like I'm multiplying here, all of my y values by -1/2. So we'll do -1/2 y. So again, just like I'm multiplying by -1/2 in the equation, that's exactly what I'm going to do to transform my coordinates. So let's start by doing the x values. So we're going to add 1 to all of these x values. So we have -1, 0, 1, 2, and 3. And then we're going to multiply all of our y values by -1/2. So this becomes -1. This becomes -1/2. 0 stays 0. This becomes -1/2. And this becomes -1. So this is a set of our new coordinates, and now we can graph. So if you want, again, you can graph the parent function. So our parent function looks like this. And now we can plot our transformed coordinates. So we have -1, -1, 0, -1/2, 1, 0, 2, -1/2, and 3, -1. So our graph looks like this. So you can see by comparing our parent function, p of x, to our new function, f of x, the original function, it was reflected, so we flipped it upside down. And then you can see that it is a vertical shrink. It looks a little bit flattened, so here it's a little bit wider than it was, and everything was shifted to the right one. So it is important to note when we're doing these transformations, we always do anything involving multiplication first, and then we can do that addition or subtraction. So this is what our graph looks like, and let's see if we can define the domain and range. So our domain, again, is going to be all real numbers, because we're moving to the left and right forever. And then our range, remember our y values, I can see is everything from 0 down. So remember, we always start with our lowest boundary. Since it's going down forever, our lowest boundary is -infinity. And then we go to our upper boundary, which is 0. And 0 is included, so I will do a bracket. All right, so go ahead and pause the video and see if you can give this problem a try. Make sure to fill out the t-chart completely and graph and try the domain and range. All right, so go ahead and check your work. Here we had 3 transformations. We had a vertical stretch by 3. We are shifting to the left 1, remember it's opposite, and we're shifting down 4. So to change your coordinates, to go left 1, we subtract 1 from all of our x values. Since it's a vertical stretch, we're going to multiply 3 to our y value. And since we want to go down 4, we're going to subtract 4 after. So these should be the new coordinates of your function, f of x. So you can see here I plotted my parent function and my new function. And you can see that it does look like it was stretched vertically. It's stretched up, it's a little bit skinnier and narrower. And all of the points did move left 3 and down 4. Then here's your domain and range. So all real numbers, and then from -4 to infinity. Okay, so now we're going to talk about a different way that you can graph absolute value functions. It's good to start practicing using those transformation rules because we'll use them with other functions this year, but we can also kind of use a more general form of the equation. So here's that same equation, a times the absolute value of x minus h plus k. So you might have noticed that whenever we're shifting our graph left, right, up, or down, the first thing that is going to move, or a key point that moves, is your vertex. And your vertex is actually always going to be hk. So notice that if this says minus h, it becomes a positive h, so it's going to be opposite of the h, and then the k matches. So you can first look here and say, okay, what is my vertex, and then plot that first. Then that a value, whatever this a value is, you're going to use it as the slope of your graph to the right of the vertex. So if it's positive, you're going to go up to the right, and if this is negative, you're going to go down to the right. And then on the other side of your vertex, you're essentially going to reflect it. You're going to use the opposite of a as the slope of your graph to the left. So this is just a different way we can approach graphing absolute value functions, and you might find it a little bit easier. So again, start with the vertex, which will always be hk, and then use a as the slope to the right. So let's give this a try. Here we have f of x equals 2 times the absolute value of x minus 3. So let's start with that vertex. Here I don't see anything added or subtracted from x, so our h value is 0. And this would be our k value right here, -3. So our vertex is 0, -3. So we can start by plotting that point. And then here we can see that our a value is 2. So that's going to be the slope of our line moving to the right of our vertex. So we can start here, and we'll just go up 2 over 1, up 2 over 1, up 2 over 1 for as far as you can. And then we're going to do that opposite slope going over to the left. So we're going to essentially reflect it across the vertex. So we're going to do up to left 1, up to left 1, up to left 1, up to left 1. And there you go. And this is the same exact graph that you would achieve if we were using the transformation method that we talked about earlier. So here's the graph, and then we can see, or here we can try to define the domain, which of course is all real numbers. This is moving left and right infinitely. And then our range is going to be everything from -3 and above. So -3 is our lower boundary. It is included, so we use that square bracket. And then it's going to go up forever, so it goes to positive infinity. Okay, let's try another one together. So here we have -1/2 times the absolute value of x minus 3 plus 4. So let's first start by just finding that vertex. Remember, it's hk, and the thing to remember is that it's opposite of h, so it's actually +3, and then it's whatever you see for k, so 4. So our vertex is going to be at 3, 4. And then our a value here is -1/2. So our graph to the right, we're actually going to follow a slope of -1/2. So we can go down 1 over 2, down 1, right 2. So that's going to be our graph moving to the right. And we can do the opposite going to the other side of our vertex. Down 1, left 2, down 1, left 2, down 1, left 2, for as far as you can. And there you have it. So again, our graph has a slope of -1/2 on the right and +1/2 on the left. So here is our function. So here, again, our domain is going to be all real numbers, -infinity to +infinity. And our range we can see is everything 4 and below. So let's start with our lower boundary, which would be -infinity, since it's going down forever. And then our upper boundary is 4 with a bracket. So again, we start with the vertex, and then we can use this a value as our slope moving to the right. All right, so go ahead and pause the video and see if you can try graphing this one on your own. And when you're ready, hit play to check your answer. Okay, so remember we start with our vertex, which is always HK. Remember, it's always opposite though, so it's actually -1, 3. And then our a value is actually just 1, so that means that we're just going to go up 1, right 1, up 1, right 1, and then reflect that going to the left. And then we have a domain and range listed here. Okay, here's the last example in this video. So again, please pause the video and give it a try, and when you're ready, hit play to check your answer. Okay, so go ahead and check your work here. So remember, our vertex is always going to be HK, so opposite of HK. And if it helps, you can write +0 to show that our K value is 0, but you don't need to. So here's our vertex. Our A value is -2, so from the vertex, we follow that slope going to the right, down 2, right 1, down 2, right 1, and reflect it going to the left. And then here's our domain and range. Notice our range is low to high, so -infinity to 0 and including 0. Okay, that is all for today's video. Thank you so much for watching.